In this video, we are looking at two different companies, rental car companies. I've got a spot on my screen. It says the graph below represents the cost for Mary to rent a car to drive from Memphis to just outside of Nashville to visit her brother. So let's take a look at our graph before we dive into the questions. The best rental company is shown in dashed line. The happy rental company is shown in solid. And I can tell you just by looking at the slopes of the lines, the visible slopes, that the dashed line has a more gentle slope. It's not sloping near as fast and high as the bottom one is. Over on the y-axis, they're showing me the cost in dollars for these rentals. And then at the bottom, they're showing me the miles driven over 150. Now that's important. When you look at this bottom row and you see a 0, that doesn't mean that 0 miles were driven. It means that 150 miles were driven. The graph is just showing us everything over 150. So this one would actually be 150 plus 5, 150 plus 10, 150 plus 15, 150 plus 20. And I'm just going to go ahead and finish those numbers all the way up because I like to see those. Just be careful reading your graph. Okay. Let's go ahead also and find the slope of each line. I know that this top one is a gentler slope. It should be a smaller number, but I would really like to know what that number is. So I'm going to use the intercept and another point, looks like right here. This is at 30, 40. And this point is at 0.32. And let's find the slope. So slope is rise over run, 40 minus 32, and 30 minus 0. That's going to be 8 over 30. And when you divide that through, I'm guessing 28, maybe, I don't know. 8 divided by 30 is 26.6, so it would round to 27. So about 27 cents per mile. I'm glad I didn't estimate. And then down here, let's do the same thing. Let me get a different color. I'm going to use the intercept, which is at 0 miles, $10. And here's one that's close. Let's just use 10 and 15. Again, the slope formula is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's 5 over 10, or 50 cents per mile. Again, that's consistent with what I'm seeing because the slope on this line is steeper. The slope on the top line is more gentle. So which rental company is the least expensive? Which one of the companies has the gentlest slope? I didn't even have to work this to know the answer to that, but I wanted to remind you how to find slope. it's going to be the Best Rental Company, because 27 cents a mile is cheaper than 50 cents a mile. If you only drove 150 miles, how much would your rental cost at Best Rental? So this is saying when X is 150, what is Y? Well, remember these are measured in increments above 150, so the 0 mark is the 150, and we're looking at Best Rental Company. That's going to be $32. If you drove 180 miles, how much would your rental cost at Happy Rental? Well, we found on Happy Rental that it's 50 cents a mile, so we would say that the cost is 50 cents a mile plus, remember we're looking at anything over 150, so 180 minus 150 is 30. So we're only looking at 30 miles. But we also have to come back and add in that $10 that we had for the 150 miles that had been driven. So that would be plus 10. So we have 0.5 times 30 is $15. Add 10 to that, so the cost is going to be $25. Now, let's see if this is consistent with our graph. So we're looking at 180 and 25. So you come up here, here's 180 total, or you could do it by 30 extra over 150. 180, look at that, $25. So our math is correct. You could also have just looked at the graph. If you drove 180 miles, how much would your rental car cost be at Best Rental? Again, you can do the same thing. Go to this 180 and up to this line, and there's 40. But let's see if that's going to hold true mathematically. So we're taking 180. We're taking away the 150 because we've already paid for that with the intercept. That leaves us with 30 miles. And so the cost formula is going to be, what was it? 27 cents a mile. And we want to go 30 miles. But we had that starting point of 32, so we have to add that in. So let's do 27 cents a mile for 30 miles. 27 times 30 is $8.10 plus 32 is $40 and a dime, which is consistent with my graph. Okay, now hopefully you have noticed something about number 1. I did this on purpose. I was hoping that someone is already thinking something's not right there, because I'm saying that the best rental company is less than the happy rental company. What I wrote here is that yes, it is the best deal if you're just figuring miles. What we cannot ever, let me rephrase that, we can never underestimate is the power of this starting point. I can tell by the gentleness of the slope that this is cheaper per mile. But you have to account for this starting point. The intercept always has to be added in. So to answer question A, yes, it's cheaper per mile, at least after 150. That's all I can see on this graph. But when you factor in the intercept, it's not going to be cheaper all the time, even though it's the gentler slope. Now, when these two intersect, the condition changes. The bottom company would become a different situation. So what I want you to notice about question A, personally, I don't think this is a good question. We need to know the number of miles. Because at sometimes, happy will be cheaper, but especially later on in this graph, when the lines actually intersect and happy continues to climb, best will be cheaper. So the cheaper, the least expensive, is going to depend on the number of miles. And I wanted to let you see that in C and D. If that didn't click, if you didn't catch it, it's okay. Just be aware of it, that it's going to depend on M. If you're just comparing slopes, miles to miles, best is cheaper. But if you're comparing the total cost of the whole thing, you have to factor in the intercept. All right. E says to write an equation for best car company rental where Y represents the cost of the trip and X represents the miles driven over 150. So the best car rental, we're going to say Y is, or cost is, for best, that's the dashed line, and we found that that's 27 cents a mile. But you have to factor in the intercept. That's after you've traveled the 150 miles or spent the $32. Let's put this equation to the test, and let's see if it proves to be true. I'm going to use the 30-40 point that I had up there, and I'm going to say that Y is $40. 30 miles. Now remember, I rounded on these, so it may not be spot on, but it needs to be close. 0.27 times 30 is 8.1, plus 32 is $40 and 1 dime. So this is close. Given the fact that I rounded, I'm going to say that's correct. That's close enough given the rounding to fit. So my equation is good. That's a workable equation for that particular graph. But the actual answer that they want there is just the equation. They don't want you to go in and do all that other stuff. I just want you to see that it works. Okay, we're supposed to do the same thing for happy car rental where Y is cost and X is miles over 150. So we know the slope on that one is 50 cents per mile. y is 50 cents a mile plus your starting point, which was 10. So yes, you're paying more per mile, but your starting point is lower. And this is the equation they're looking for. But let's check it out. Let's see if it fits. I don't think this one involved rounding, so it should fit exactly. I'm going to use 10 and 15 as my point. So 15 is the cost if you drive 10 more miles. So here we have $5 plus 10, and look at that. That equation proves to be true, so we know that it fits that line. This was a very good set of problems. Except for question A, I like all of these. I like question A. They just need to tell you based on how many miles. If you're just comparing mile per mile, that's one thing. But if you're including the starting point, that's something else. So I would have reworded that one a little differently. But hopefully this has helped you understand a practical way to use this skill.